When you're going about describing a data set, in addition to sort of saying where the middle of the scores is, you also need to describe how spread out those scores are, the variability. We're going to calculate common measures of variability by hand using this data set of 10 scores that I've already calculated the mean for, as well as ordered from least to greatest. Now, the first and quick and simplest measure of variability is the range. Find the max score, subtract the minimum score from it, and what is that difference? In this case, 7 minus 2 gets us 5. The primary disadvantage of the range is that it doesn't take into account every single score in the distribution. This next measure of variability, the sum of squares, does do that. Now, simply put, it is just the sum of the square deviations from the mean. And if you look at the definitional formula, you can really see this, where we sum up the difference of every x score from the mean and square it. When you're calculating the sum of squares using the definitional formula, use the table. Give yourself a column for just the mean deviations, and then calculate each of those mean deviations by taking that raw score, subtracting the mean from it, and then in the next column, square all those deviations. Working it all out line after line after line after line in the formula over to the right, you're likely to make an error. One other thing to note is all of the deviations to the mean should add up to 0 in the end. So here we are at 20.4. There is a computational formula as well. This is the advised route because you're less likely to make an error, just simply because there's fewer keystrokes and you don't really have to worry about as many decimals. Again, this is a situation where use the table. It will make your life easier. Square all the x scores in the table, add them together. Then you can substitute that number into the formula. You've already summed up all the scores. You're just taking the square of that. You already know how many scores there are. And so it's really just kind of plug the numbers into your calculator and run it out the rest of the way. Again, this is the preferred method. You're less likely to make an error, but it's not intuitive what sum of squares actually is in this case. Now, sum of squares is not typically used as a measure of variability in and of itself, because if you have more scores in the data set, your sum of squares will be greater. So it's confounded by the number of scores. To get around this, you would calculate variance, where you actually take the sum of squares divided by the degrees of freedom. Now, degrees of freedom is actually a complex concept. If you remember, all of those deviations from the mean should add up to 0. So if we look at these scores, the first 9 of these can be any score that they want to be. However, that last score in the data set has to be exactly the value that is needed to make that sum of those deviations add up to 0. So it's not free to vary. Hence why we have degrees of freedom of n minus 1, because we have n scores, one of which is not free to vary. So 20.4 divided by 10.1 gets us 20.4 divided by 9 for a variance of 2.266 repeating. Now, one way to interpret variance is that it is the average squared deviation from the mean. However, this isn't very interpretable and very intuitive on a basic level. So the common measure of variation that you'll typically see is standard deviation, which is really just the square root of variance, but it tells you, and you would interpret it as, the average deviation from the mean. So we just take the square root of variance, which gets us approximately 1.51, rounding to 2 decimal places.